Welcome back. We're looking at finding the equation of an ellipse given the graph of the ellipse. So first thing to count before you decide what the equation is, we can kind of write off the generic equations to the side if you'd like. I kind of prefer to find the center first. So let's see what we can do. I'm going to mark this with red. With our pictures, we're going to have to eye it, but I'm sure we can end up counting as we go. When I'm looking at part A, I feel like I have a midline, so maybe I can draw dashed lines to help me see. They are for sure not centered on the origin, so that's going to be a little more difficult to determine. So I'll kind of draw a quick dashed line through what I think the center is, and then I can kind of count and verify as I go. So I'll kind of see what I can do. So let me make sure. If I'm counting outwards from the center, let me see, I have 1, 2, 3, 4, 5, 6, 7. That's coming to the left. Oh, excuse me, right. Now for the left, 1, 2, 3, 4, 5, 6, 7. So it looks like my vertical line is properly placed. That also kind of gives me a heads up that I could label the distance, because we'll need that in a few seconds. Also, I'm going to count up and down just to make sure. I'll do this in a different color. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll label that, and then I'm just checking to see if I can also count 9 units as well. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So I'm confident at this point that I picked the right midlines, vertical and horizontal, so that I could kind of plot my center just so I can actually count what it is. So remember, when you identify what the center is, you're always counting from the origin. And when you look at the graph, sometimes the origin's not right in the middle of your grid. So just kind of pay attention to the bold lines. I do see my origin about right here. So I'm going to highlight that in yellow a little bit. So if I'm counting, I'd have to go to the right. 1, 2, 3, 4. So that the X value would be 4. And then I'd go down 1. The Y value would be -1. So I always felt like that's kind of the roughest part. The other thing you're going to want to decide is if you have a horizontal or a vertical ellipse. And you can kind of eye it right away just by how we counted outwards from the center. To me, it feels, actually we know for sure, that the ellipse is elongated vertically. So what I'll be kind of just making sure is I just kind of note to myself, I do have a vertical ellipse. So that's going to tell me the generic form of the equation. I have x minus h squared. And then if it's a vertical ellipse, remember the a, on all of the ellipse equations, the a is going to be bigger than the b. So that would mean that the term under the x minus h squared is actually going to be the b squared. So then we have plus y minus k squared over a squared equals 1. So now I have my generic equation, and then my job is just to kind of fill in who's hk and who is a and b. Now, just kind of looking at what we've labeled, we correctly identified the center. We could already tell that a is equal to 9. So if you'd like to, you could kind of replace them as we go. So I'll do that. So I have 9 squared, that's A. And B is equal to 7, that's the shorter distance. And if you're not sure what I'm talking about, let's go look at the distances again. I have my A and then my B. So let's have this 7 squared. Now, last thing, we'll probably have to simplify what's 7 squared and 9 squared, but I do want to also identify where my center is. So let's write that in. X minus h, so it's going to be x minus 4. And then y minus k, I'll color code that for you. I don't want to put the k in there quite yet. That's a -1. So remember, if you're subtracting off a -1, you're actually adding it. So it's a little different than what you see from the formula, but remember, it's the opposite of what you see. So the very last step is to just make sure we simplify everyone. So we have x minus 4 square over 7 squared is 49 plus y plus 1 square over 81, that's 9 squared equals 1. And now you can see we have identified the equation just by looking at the graph. So hopefully that's helpful. I want to do one more with you, at least part B, and then I'll let you try C on your own. Let's look at part B. Again, I will try to draw a midline, vertical and horizontal. Right now I'm eyeing it, but I'll count to verify. I believe a horizontal midline kind of looks to be, or appears to be, somewhere around here. Also, it looks like the vertical midline is probably over here. So we're just going to check. You can kind of already tell what kind of ellipse it is. It's the opposite of what we found in part A. We actually do have ourselves a horizontal ellipse. So if that gets the gears in your brain going, no matter what an ellipse is, the A is always bigger than the B. But with horizontal ellipses, the larger number is located under the x term. So I have y minus k squared equals 1. And so this time around, we're going to have the a square located under the x squared term. So at least we have that set up. So let's count that distance horizontally from what we think the center is. Each way, just make sure we're verifying. 1, 2, 3, 4, 5, 6, 7, and 8. So we'll count the other way to double check. 1, 2, 3, 4, 5, 6, 7, 8. We are good to go. So we have our A. So I can replace that right there. So it'll be 8 squared. Kind of see me filling in the equation as we go. So now for sure we've got that the vertical midline correct. I'm going to count vertically up and down to see if I got my horizontal midline correct. So from this, what I think the center is, I'm counting upwards 1, 2, 3. And then downwards 1, 2, 3. And you do see I end up on the ellipse. So we're pretty good. We have our B is equal to 3. So that's going to be 3 squared underneath the y squared term. We'll kind of fill in the format of the equation. This further gives me the confidence that I really do know where my center is. So I might want to even label it or just note it out loud to myself. And remember, we're counting from the origin. So if we're going to count to figure out where the center is, I have 1. Oh, sorry, I'm using my highlighter. 1, 2, 3, 4, 5, 6. So that's 6 to the right. And that's actually kind of the same. It's 1 down. So that's -1. So when we enter this in the actual formula, we're going to go through this. So it's x minus 6 is very similar to part A. So x minus 6 squared. Kind of keep in line with the formula. And then the y value is the same. It is y minus a -1. So that's going to give us y plus 1 squared. So then the very last thing you have to do is just make sure you're simplifying the square numbers in the denominators for each of the terms. So the equation of the ellipse for part B, I should have x minus 6 squared over 64 plus y plus 1 squared over 9 equals 1. And you could kind of double check if you're kind of comparing your ellipse. If you're a horizontal ellipse, remember that you are wider with an X, so the bigger number is always under the X term. And just like we did with the vertical ellipse, notice that it was a little bit longer vertically, so that's why the bigger number was under the Y term. So I hope this helps and gives you enough information to see if you can try part C on your own. Just kind of keep in mind, we graph these with a TI, and don't be thrown off with the fact that it looks like there's two separate ellipses. You could go ahead and connect that visually if you'd like. That's just kind of the limitations of some of the technology when we graph some versions of the ellipse. So I hope this helps. Practice these a lot. It'll be nice. It kind of gives you a good experience when you actually have to graph them from the equation. So I'll see you in the next example.